In 3 seconds, our solar system will travel more than 370 miles through space. And do you know what we're passing through? Did you know that right now, as you're watching this video, you are literally traveling through a supernova graveyard? No, this isn't a metaphor. This is pure physics. Our entire solar system is immersed in superheated plasma at 1 million degrees Celsius, the blazing debris from at least 15 catastrophic stellar explosions that happened millions of years ago. And here's the part that will make you rethink your position in the cosmos. We're not just passing through this region by chance, we're surfing through it, carrying with us the evidence of these ancient cosmic catastrophes recorded in the depths of our oceans and even on the surface of the moon. So if you want to discover how scientists unraveled this extraordinary cosmic story, and I guarantee it's more fascinating than any science fiction movie, how they found clues of stellar explosions buried at the bottom of the sea, and why this discovery is rewriting our understanding of star formation in our galactic neighborhood, then you need to stick with me until the end of this video. And since you've made it this far, how about hitting that like button and subscribing to the channel? Because what I'm about to tell you will completely change how you see the space around us. But before we dive into this cosmic journey, let me ask you a question. Have you ever wondered why space isn't completely dark? Let's start this story in the 1970s. Imagine you're an astronomer, pointing your instruments at the night sky, when suddenly you detect something completely unexpected. Low-energy X-rays coming from all directions, not from a specific star, not from a distant galaxy, but literally from the entire sky. It was as if space itself around us was glowing with a light invisible to our eyes, but detectable by our instruments. Scientists were intrigued. What could be causing this diffuse radiation that seemed to envelop us completely? Now you might be thinking, okay, but X-rays in space, what's the big deal? Well, let me explain why this was so revolutionary. The hypothesis that emerged was as audacious as it was fascinating. Perhaps we were inside a gigantic bubble of superheated gas, a cavity in the interstellar medium created by supernova explosions. They called this hypothetical structure the local hot bubble. But here's the problem. How do you prove you're inside something that is by definition almost empty? How do you map an invisible structure that's 1,000 light years in diameter when you're trapped inside it? The answer came from a completely unexpected source. The answer came in 2014, when NASA finally confirmed our suspicion through the DXL mission, diffuse X-ray emission from the local galaxy. The data was unequivocal. Only 40% of the low-energy X-ray fog we detected came from within our solar system. The other 60%, it came from the interstellar space around us. We were officially living inside a cosmic bubble of million-degree plasma. But how do you find evidence of something that happened millions of years ago? But the story gets even more extraordinary, because the scientists didn't stop there. They wanted to know when and how this bubble formed. And to do that, they did something brilliant. They went looking for evidence in the most unlikely place possible, at the bottom of our oceans. Let me explain the logic behind this cosmic detective investigation. When a supernova explodes, it doesn't just release energy. It forges elements that don't exist naturally on Earth. One of these elements is iron-60, a radioactive isotope with a very specific temporal signature. Now here's a mental challenge for you. If I told you we found atoms at the bottom of the ocean that traveled 300 light years through space to reach us, could you imagine how much energy was needed to make that happen? Iron-60 is like a cosmic clock. It has a half-life of 2.6 million years, which means half of it transforms into cobalt-60 every 2.6 million years. Cobalt-60 in turn has a much shorter half-life, just 5.3 years, before it transforms into stable nickel-60. So when you find these elements in specific proportions, you can calculate exactly when that material was deposited on Earth. It's literally like reading the expiration date of a stellar explosion. And before you ask, no, you won't glow in the dark because of these radioactive atoms. The amount is so small that you'd need extremely sensitive instruments to detect them, but they're there, like cosmic signatures of events that happened when our ancestors were still small mammals. And then came the discovery that changed everything. And in 2016, international research teams led by Anton Wollner and Dieter Breichwert made a discovery that changed everything. They found iron-60 deposits in deep-sea crust samples from the Pacific, Indian, and Atlantic Oceans. Not just in one place, but globally distributed. The data revealed two distinct peaks of radioactive debris, one between 3.2 and 1.7 million years ago, and another between 6.5 and 8.7 million years ago. This wasn't evidence of a single supernova. It was evidence of multiple stellar explosions happening in succession, like cosmic fireworks exploding one after another. But who were the culprits behind this cosmic transformation? Scientists traced the origins of these explosions and discovered that the supernovae that created our local hot bubble probably came from ancient stellar clusters, specifically from the Scorpius-Centaurus stellar group. Picture the scene. 14 million years ago, massive stars, some 8.8 times the mass of our Sun, others 9.2 times, reached the end of their lives in spectacular explosions. One after another, at least 15 of these stellar giants exploded in a relatively short period of cosmic time. Stop for a moment and think about this. 15 stars, each one larger than anything we can imagine, all exploding in a relatively small region of space. It's as if the universe decided to put on a cosmic power demonstration right in our neighborhood. Each explosion released more energy than our Sun will produce in its entire 10 billion year lifetime. The shock waves propagated through interstellar space at unimaginable speeds, sweeping gas and dust like a cosmic hurricane. The result? A gigantic low-density cavity, our local hot bubble, filled with superheated plasma that continues expanding today at 4 miles per second. And here comes the part that will make you rethink our journey through the galaxy. Now, here's a fascinating detail that will make you rethink our position in the cosmos. Our Sun wasn't born inside this bubble. When the first supernovae exploded 14 million years ago, our solar system was almost 1,000 light-years away. We literally traveled through the galaxy and entered this region just 5 million years ago. It's as if we were cosmic explorers who by pure coincidence ended up navigating through the debris of ancient stellar battles. But the most revolutionary discovery was yet to come. In 2022, astrophysicist Catherine Zucker and her team did something that seemed impossible. They created a 3D map of our galactic neighborhood using data from the European Space Agency's Gaia telescope. And what they discovered was absolutely revolutionary. And when I say all, I mean all. The young stars and star-forming regions within 500 light-years of Earth are located on the surface of our local hot bubble. It's not a coincidence. It's cosmic cause and effect. Can you imagine what this means? That all the baby stars we see in our night sky are literally daughters of the explosions that created our cosmic bubble. You see, when the shock waves from the supernovae expanded, they didn't just sweep away the interstellar material, they compressed it at the edges of the bubble. And when you compress cosmic gas and dust, you create perfect conditions for the birth of new stars. It's as if the violent deaths of these ancient stars planted the seeds for an entire new generation of stars. Cosmic destruction became cosmic creation. Zucker and her team discovered that this star factory worked in shifts over millions of years. First came the stars of Scorpius and Ophiuchus, then Corona Australis and Taurus, followed by Lupus and Chameleon. And now, at this very moment, we're witnessing the formation of new stars along the edge of the bubble. It's like watching a cosmic assembly line in slow motion. But our bubble isn't alone in the universe, but the story gets even more incredible. We discovered that our local hot bubble isn't unique. The entire Milky Way is like cosmic Swiss cheese, full of cavities created by supernova explosions, with new stars forming along the edges of holes created by stars that died. And just like Swiss cheese has tunnels connecting different holes, our galaxy has interstellar tunnels connecting different bubbles of superheated plasma. The Eurosighter telescope revealed at least 2 of these tunnels connected to our local bubble. The first is the Canis Majoris tunnel, which seems to connect our local hot bubble to the famous Gum Nebula. The second is a newly discovered tunnel extending toward the constellation Centaurus. Imagine, we're living inside an interconnected network of cosmic structures, all sculpted by the violent death of massive stars over millions of years. Now, you must be wondering, if we're surrounded by million-degree plasma, why aren't we being cooked alive? Imagine you're inside a giant oven, but an oven so empty that it has only a single air molecule per cubic meter. Even though that molecule is extremely hot, there aren't enough molecules to transfer heat to you. That's exactly what happens in our cosmic bubble. Extreme temperature, but density so low it's practically a vacuum. And this brings us to the deepest question of all. So, the next time you look at the night sky, remember this. You're not just observing distant stars. You're looking through a cosmic window created by the violent death of stars that exploded millions of years before the first hominids walked the Earth. Those stars you see, many of them are young, born at the edges of our cosmic bubble, daughters of shockwaves that still reverberate through interstellar space. But here's the question that keeps me up at night. If our cosmic journey brought us into this supernova graveyard that became a stellar nursery, what other cosmic wonders are we destined to encounter on our trip through the galaxy? And perhaps the deepest lesson of all this is this: nothing in the cosmos exists in isolation. The death of massive stars 14 million years ago created the conditions for the birth of all the young stars we see today. Our journey through the galaxy brought us into this cosmic cathedral sculpted by ancient catastrophes. We are literally cosmic travelers navigating through a supernova graveyard that became a stellar nursery. We carry with us, in the sediments of our oceans, the chemical signatures of these primordial explosions. Remember when I said at the beginning that you're navigating through a supernova graveyard? Now you know it's not just a journey through cosmic death. It's a journey through the eternal cycle of death and rebirth that defines our universe. If this journey through our cosmic supernova graveyard sparked your curiosity about the mysteries of the universe, then you definitely need to subscribe to this channel and hit that notification bell. Because every week I bring stories like this, scientific discoveries that reveal surprising connections between us and the cosmos, that show how we're part of a much larger and more extraordinary narrative than we imagine. And tell me in the comments, after discovering that we're literally navigating through debris from stellar explosions, how has this changed your perspective on our place in the universe? Do you feel more connected to the cosmos, or more insignificant in the face of immensity? I want to know your thoughts. And if you found this story incredible, in the next video we're going to explore something even more fascinating: how these discoveries are helping us search for life on other planets. Because if our cosmic bubble influenced star formation here, imagine what might be happening in other regions of the galaxy, where similar explosions created perfect conditions for life. The cosmos has many more secrets to reveal, and I can't wait to share them with you. Until the next cosmic adventure.